So welcome back, guys. This is going to be a quick one. This is really pre-calc stuff, but we need to go over it. So you need to have certain values of trig functions memorized. So this table and this unit circle should help you do that. All right, so let's start off with this. Cosine of 30 degrees, or better yet, the cosine of pi over 6 radians. Turns out that is going to be radical 3 over 2. Okay, now I put degrees on this table really kind of for your reference, but we will always be working in radians, so keep that in the back of your head, right? So start getting comfortable with them. It actually turns out that the cosine of 30 degrees is the same thing as the sine of its complement, right, or the sine of 60 degrees. So the sine of 60 degrees or the sine of pi over 3, that is also radical 3 over 2. So it's important to kind of see these patterns, so it's just going to make it that much easier for you to memorize. All right, let's go to this guy, cosine of 45 degrees. Well, that's going to be radical 2 over 2. It's funny, I clicked on blue and red's coming up. Computer's going bananas today. All right, what about the sine of 45 degrees, or the sine of pi over 4 radians? So that's also radical 2 over 2. They're the same thing, which again makes sense because the sine of an angle is equal to the cosine of the angle's complement, right? And 45 degrees is its own complement. Then we got over here, let's do cosine of 60 degrees, right? Well, it turns out that that is a half, right? Cosine of pi over 3 is 1/2. Well, that's the same as the sine of 30 degrees, or the sine of pi over 6, okay? So that is also a half. So you can kind of see how these work, right? Cosines going radical 3 over 2, radical 2 over 2, radical 1 over 2, if you wanted to think of it that way, but radical 1 is just 1, right? And then sine does the opposite. And again, I'm just pointing that out is because you have to have this stuff memorized. So you might have to build this table a couple of times as you do homework, as you do a test, right? The first thing you do is you write this down, and then eventually you won't have to do that. Eventually it'll go in your brain. And just to drive home the fact of what these things are, I feel like I should probably write this. These are the radian measurements, and obviously you can see the symbol. These are the degree measurements. All right, tangent's the one that's a little wacky, right? So tangent of 30 degrees, a lot of threes, that's how I remember it. I know that's stupid, but that's what I do, is radical 3 over 3. A lot of threes, there's 2 3s there, kind of, right? So tangent of pi over 6, radical 3 over 3. Tangent of 45 degrees, easiest one in America. Why? Because the answer is 1. That's how I remember it. Tangent of pi over 4, easiest one in America, it's 1. Tangent of 60 degrees, right? Not a lot of threes, just 1 3. It's radical 3. Right? So tangent of pi over 3 is just radical 3. That's makes no sense how I remember it that way, but that's literally how I remember it. You got to figure out what's going to work for you. So there you go. So there's a table for the special angles, pi over 6, pi over 4, and pi over 3. So now what do you do about those special quadrantal angles? Like 0 degrees, 90 degrees, 180, 270, 360, and so on and so forth, right? First off, notice I'm not putting degrees here, I'm putting radians. So this is 0 rotation, 0 radian rotation. Then you get to pi over 2 at the North Pole. I commonly refer to it as the North Pole, right? Then you have pi. Then you have 3 pi over 2. Guess what I call that? The South Pole. And then you're back to coterminal with 0, which is 2 pi. And you can actually rotate the other way as well. I could do negative pi over 2, negative pi, negative 3 pi over 2. Or I can rotate all the way around. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. Then 5 pi over 2, which would be coterminal with pi over 2. So you can get all those different ways of representing those radian measurements. Now, how do you do sine, cosine, and tangent? Well, it's pretty simple, right? So the x values on the unit circle are going to correspond to the sine of your rotation. So the sine of, I'll say theta, right? And the y value, I just screwed that up royally. Oh my goodness, I am a mo. Should I keep this or should I delete it? I'm not deleting the video. I'm keeping it. Can't believe I just said that. I'm on another planet. X corresponds to the cosine values, right? And Y corresponds to the sine values. And we remember that because X becomes before Y in the alphabet, just like C comes before S, right? I've only taught this for 25 years and I just screwed that up. All right. And then what's tangent? Well, tangent is actually the Y divided by the X. And that's how you use this. Wow, the thing is going bananas. I'm going bananas. The computer's going bananas. This whole thing is bananas. All right, so like, what do you mean? That's how you use it. Well, if I wanted to do, say, the cosine of pi over 2, I would use the unit circle. What would I do? I would go over to pi over 2, that's right here, and then I would pluck off the x value. Right? That's what we're saying here. So the cosine of pi over 2 is 0. Right? If I wanted to do the sine of 3 pi over 2, right, I'd go over to 3 pi over 2, right? And now I would pluck off, what do you think? The y value there, and so on and so forth. I can get crazy, and I can do like the tangent, let's just go bananas, of negative 3 pi over 2. Okay, what's that going to be? That's the bell. All right, well, negative 3 pi over 2, I got to rotate this way now. Negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2. So this is where negative 3 pi over 2 is. It's the North Pole. Now, tangent is the y divided by the x. So that would be 1 divided by 0. And in our world, that's not defined, right? So that would not be defined. And that's how you can use the unit circle to figure out trig values pretty easily. Okay, so memorize this, write it down. Hopefully you remember it better than I do. And hopefully your work is better than my work. That makes no sense. All right, have a good day. Peace.